water covers about 70% of the Earth's surface, and exchanges between the oceans and the atmosphere have a huge role in determining the present-day Earth climate, as well as any potential future climate change. So it's really no surprise that you would find an oceanographer in a Department of Meteorology. And we're joined this evening on Weather World by Dr. Ray Najjar, the resident oceanographer in the Department of Meteorology at Penn State. Welcome to Weather World, Ray.
It's great to be here.
Hey, now, Ray, I have to admit, as an atmospheric scientist, I probably spend too much time looking up and not enough time thinking about what underlies the atmosphere, that is, the oceans.
Yeah.
Do you find that the oceans are getting the proper amount of respect from atmospheric scientists these days?
Yes, I do. I mean, there are many graduate programs, for example, that have atmosphere and ocean sciences integrated. There's recent climate reports that have been written, have integrated atmosphere and ocean sciences very effectively. So I think each discipline recognizes the importance of the others.
And I suspect that the El Nino and La Nina that are always out there in the public have really intensified research into the links between atmosphere and oceans.
Yeah, that's true. And there are many other associations as well, in addition to the more obvious exchange of heat and fresh water between the atmosphere and the ocean. The things that I'm interested in particular are gases that are transferred between the atmosphere and the ocean that are important for both systems. So, for example, carbon dioxide is taken up in large amounts by the ocean, and the uptake of CO2 by the ocean is effectively making the climate change that we might see in the future less intense than if the ocean weren't there at all to take up some of this greenhouse gas.
So the oceans are effectively a sink for atmospheric carbon dioxide.
That's right, yeah. And other gases that are of interest to atmospheric scientists and to meteorology in general are sulfur gases, and the ocean is actually is a source of sulfur gases to the atmosphere, and one of the most important gases is dimethyl sulfide, which eventually become cloud condensation nuclei, and these are very sparse over the ocean. So the source from the ocean is extremely important to the level of cloudiness at sea and that sort of thing.
And that studying the DMS, the dimethyl sulfide, was one of the reasons. I know you took some time off about a year ago and headed to Antarctica.
Yeah.
What was that all about?
Right. That was a great opportunity for me. We were studying the cycling of DMS in seawater, and we went to Antarctica as a site that's actually very biologically productive. The water there is biologically productive, and we contrasted that with some earlier field work in the Sargasso Sea, closer by in the Atlantic, which is very biologically unproductive. So we were comparing those two systems in terms of their level of dimethyl sulfide production.
And so biologically, what actually produces the DMS?
Yeah, phytoplankton. These are marine. They're aquatic organisms. They're microscopic plants, and they produce dimethyl sulfide in their tissue for a whole variety of reasons. It gets cycled around in seawater, and some of it leaks out to the atmosphere and has this important effect on cloudiness.
So basically, anything that would affect phytoplankton might affect the cloud formation over the ocean.
That's exactly right. Yeah.
Okay, well, let's move a little bit closer, because I know one of your other research passions is Chesapeake Bay, which of course has a couple Pennsylvania connections. It's a vacation destination. The Susquehanna empties into Chesapeake. What are some of the important changes that you've noted over the last couple decades in Chesapeake Bay?
Okay, well, that bay, the bay is severely degraded environmentally, and in large part because of excess amount of nutrients and sediments that have been accumulating in the bay from land use in its watershed. And my particular interest has been how will climate change affect the state of Chesapeake Bay. Warming, sea level rise, changes in flow, all of those things can have a substantial impact on the bay and on efforts to clean up the bay. So is it going to help or hurt efforts to clean up the bay? Those are some of the questions we're trying to answer.
Right, and anytime you mention climate change, of course, there's the question of uncertainty. Is there anything we can say with any degree of confidence about potential future climate change's effect on Chesapeake Bay?
That's a good question. I think it's fairly certain that the warming that we've seen is going to continue. It's even more certain that sea level rise, which is really a global phenomenon. So what happens on a global scale even affects the bay. That's going to keep on increasing. What's less certain, unfortunately, is how precipitation is going to change and how that's going to affect the flow of rivers into the bay, because the rivers have such a profound impact on the bay. And so that's standing out as a big uncertainty with lots of implications for the bay.
Okay. Dr. Ray Najjar, resident oceanographer here in the Department of Meteorology. Ray, thanks very much for taking time to join us.
It's been my pleasure.
We'll be back in a moment with a recap of the short-range forecast.